here we go. The word calculus means the ability to calculate the infinitely large and the infinitely small. And so today we're going to look at limits as x goes to infinity. And you may remember that often when we look to evaluate a limit as x approaches a, we simply plug in that a value. But that's because a is a number on the number line. Infinity is not a number on the number line. It's an expression for a very large number. And so that makes it more difficult. If you think about a polynomial, okay, like a cubic or a quadratic, okay, as x goes to infinity, what happens to the y value? As x goes towards positive infinity, yeah. But suppose we were going towards negative infinity. What do you notice? Look at the quadratic. As x goes towards negative infinity, y goes towards. But for the cubic, as x goes towards negative infinity, y goes towards. So why is that? If n is even, if you take a negative to an even power, you get a positive. So you get infinity. If n is odd, if you take a negative number to an odd power, you're going to get a negative. So it really depends. Suppose we drop them to the denominator. This is really important, okay? 1 over x to the n, and we're going to make x a very large number. Sometimes as I try to talk about these expressions, when I say I, this is the calculus book, these are professors as well, we substitute n as a very large number, okay? So you can see it's you know, a large number, so they use n for number and a capital N because it's large. Really critical. So we get 1 over a very large number to the nth power. What's going to happen to the denominator? If you take a big number to a power, it's going to get, yeah, ridiculously large, right? But so then you have 1 over a ridiculously large number. 0. That, well, then you're saying that we could never go to infinity. Right, so it'd be like 1 over. Right, so Rachel, you bring up an excellent point. That is not 0. But, you know, now take that to the 1000th power. Do you get my point that every time you try to isolate it, you could go infinitely further? Remember, folks, we're heading towards infinity, which is a big deal. It is 0. All right, this one. You can take it up with the mathematicians of the world. So you can start your own branch of mathematics. 1 over a very large negative number to the nth power. Yeah. Yeah, it doesn't matter whether it's a positive number in the denominator or a negative number in the denominator. Either way, it's going to get ridiculously small, and it's going to head towards 0. You guys, we're using the concept of limit. We say we're approaching. We're approaching, right? Okay, let's see how smart you really are, okay? As x goes to infinity of sine of x, that graph continues to bounce between what two values? Negative 1 and positive 1. So will it ever kind of just zero in on one value? No. Nope. But a lot of times people look at these limits, as soon as they see sine, they're like, oh, it does not exist. Well, that's ridiculous. Do you remember this one? Very good. Now I'm headed towards infinity. What's going to happen to 1 over x? It's going to be like sine of 1 over a very large number, which you guys said would be the sine of 0, which would be 0. Very good. Well, you could say, let's say you said this instead. It's like, well, it's not going to be 0, Mr. Guest. It's going to be 0.001. Well, no, because we could get a lot closer than that, right? I mean, it's very easy for me to just go, any number you give me, we could go past that. So 0 is the option. So use knowledge of limits to confirm the following limits algebraically. Okay, so think about the graph here. Okay, there's multiple ways we can evaluate limits as they go to infinity. Helpful to think about the graph, 4x minus 1. Okay, as x goes to infinity, what's going to happen to the y value? It goes to infinity as well. Now, some people think about this problem. They say, well, it's really 4 times a very large number, and then we just subtract 1 from it. So is subtracting 1 really going to change the value that much? No. The best way to think about this is to use a different principle. And this is what you're going to be expected to do on your test. We factor out the largest variable or largest term. Okay, we're going to factor out an x. When I factor an x out of 4x minus 1, what are you left with? 4 minus 1 over x. Very good. So let's see what happens here, okay? X goes towards infinity. We get a very large number times 4 minus 1 over a very large number. What happens to 1 over a very large number? What does that become? That becomes 0. So you have 4 times a very large number, which is going to go to infinity. Because if you take the limit of 1 over a very large number, you're going to go to 0. That'll be like, as we point out with Rachel, 1 over a million, 1 over a million to 1,000 power. You'll need to give an algebraic argument, and you'll see as we get to more challenging examples. I won't give you that problem in the test. It's way too easy. Okay. Limit as x goes to infinity, what will we factor out here? X squared, okay? Now, when people look at this problem, watch what they do. This is what the immature mathematician does. They plug in a very large number. They're like, oh, I got a very large number minus, that'll be a very large number. So basically, infinity minus infinity will be 0, okay? Perfect. Totally wrong, okay? Totally wrong. That's why when you say what's infinity minus infinity, maybe people say, well, it's 0. No, not at all. Not at all. There's different levels of infinity, and here you're going to see that work out. So you get 1 minus what? 3 over x. So we plug in a very large number. You get a very large number squared times what happens to 3 over x? Goes towards 0. Okay. And so a very large number squared times 1, that's going to go towards infinity. What do I factor out of the next one? X squared. And notice that I'm going towards negative infinity here. Okay. I get 1 minus 10 over x. What's going to happen to the 10 over x? It's going to go to 0. So I end up with a very large negative number squared times 1. If I square a very large negative number, that will give me a, so you will go towards infinity. Well, let's look at rational functions. Limit as x goes to infinity, 2x over x minus 1. I'm going to take the largest variable out of the top and out of the bottom. So x times 2 over x times what? Very good. What happens to the x's? What happens to 1 over x? Now, here's what the immature mathematician does. They say, well, I'll plug in infinity, and I'll get infinity over infinity, and so that's going to be 1. Because infinity divided by infinity is 1. No. It's 2. Ooh, so you're talking about the rate at which the infinity changes. Okay. Sounds like you're ready for L'Hopital's rule. Would you like to explain that to us? So this guy, L'Hopital, absolute dirt. This mathematics here is dirt. What do you eat for Thanksgiving? We're gonna have some dirt. All right. Let's be smarter than the problem here, okay? What's which does the numerator and denominator have a greater degree? Numerator. So as things go towards infinity, which one's going to win out? The numerator and denominator. The numerator is going to win out, isn't it? Okay, so that should affect your answer. Whereas here, which has a greater degree, the numerator and denominator? They're the same degree, so you can see you come up with 2. Watch what happens when the numerator is a greater degree. What do you factor out of the top? X cubed, now I get 4 minus 1 over x cubed over, what about the denominator? You factor out x squared, and you get 1 plus 2 over x minus 3 over x squared. Okay, so what happens to 1 over x cubed? 0, 0, 0. What happens to the x's? I'll just get 1 on top. So I get a very large number times 4 on the top, right? Or is the I'm sorry, what are we approaching? So I get a very large negative number times 4 on the top over 1 on the bottom. So that's going to go towards a very large negative number, or negative infinity. So you can see when the denominator, or when the numerator was a larger degree, that won out. It's approaching negative infinity. Does that help? Do we have 1 more minute? We do. All right. Later, Spence. All right, last one, and then we'll break for lunch. Where's the greater degree now? The bottom, okay? So what's going to win out? The denominator. When the denominator wins out, what do you think the answer is going to be? Should be 0. So we get the limit as x goes towards negative infinity of 6 over, what do you factor out the bottom? I get 1 minus 3 over x plus 7 over x squared. 0, 0, 6 over a very large negative number squared, which will give me negative 0. No, just 0. The 6 is not going to, I mean, the 6 just has no power over the denominator. I mean, look at this, Rach. Does it matter if we get 1 over a million or 6 over a million? Either way, it's going to be a very small value, isn't it? Okay. Go get some brain food, folks. All right, folks, eyes up here, okay? So, are you ready for a shortcut? Okay, watch. Now you're going to need to show your work, but here's a way to identify exactly what's going to happen, okay? Look at this. Where's the bigger power, numerator and denominator? So the denominator is going to win out, right? Bigger power, numerator and denominator. Numerator. So numerator is going to win out, right? So either you're going to get a positive infinity or negative infinity. Now watch this. Bigger power, numerator, denominator. Same, so you just take the two biggest ones and divide them. 2x over x. Here, watch. Now, you can't do this on the test, but you sure can do this on the AP exam. Okay? Watch this. Watch how nicely this works out. What's this going to end up being? You can do this on the AP exam all you want, but you can't do this on my test. You're going to need to show it algebraically. So we'll go back and show one or two of these algebraically. Oh, this one, you cube infinity, you're going to get bigger one in the numerator and denominator. Numerator, so numerator is going to win out, right? You have negative 6 times a big number squared over, I'm sorry, negative 6 times a big negative number squared divided by a big negative number, right? The square is going to make the negative go away. Now, see, exactly. So when you get confused, you work it all out. We'll work it out, but I want you to see so you can anticipate ahead of time, okay? Like, look at this one. They're the same, right? So it ends up being 4 over negative 6, which is negative 2/3. Where's the bigger one here? Denominator is going to be 0, okay? So you can do it pretty quickly. We'll work this one out so you can see, but, you know, when you get to those types of problems on the AP exam, a lot of people, you know, they spend time factoring out doing stuff. Just look at it and say what it is. So let's do this one, okay? What are you going to factor out of the top? 5 minus, or what? I'm sorry, 5 over x squared. Over x times 1 minus 3 over x. So right away, you know that those with the denominators are just going to go away, which is the total reason why we can ignore the 5 and the 3 like I did earlier. Okay? That's why you can just ignore that stuff. It just goes away anyway. And so you end up with the x squared over the x. One of the x's divide out, right? So this goes away. You're left with x to the first. So we have negative 6 in the numerator times a very large negative number divided by what's in the denominator? 1. And you get infinity. What? Because we're approaching negative infinity. Good question. Okay, look at this one. Always think of the graph. What shape does it make? Right side up or upside down? So if you're going to negative infinity, this graph is going to go to negative infinity. Let's show that. What do you factor out? You could, but I don't think that really helps you. Factor out an x squared, we get 5 over x squared minus 2 over x minus 3. What happens to the 5 over x squared and the 2 over x? 0, 0, and I get negative 3 times a very large positive number or very large negative number squared. Negative number squared. Because you're approaching negative infinity. So it'll be negative infinity. And so, you know, your work needs to confirm it, but we could tell just by looking at the graph right away what it was going to be, right? So it's a nice way to check your answer, right? So, all right, well, let's look at ones where you don't know what the graph looks like, okay? Let's look at square root of 5x squared plus 2 all over 7x plus 1. What am I going to factor out of this top, do you think? Yeah, so I got square root of x squared times 5 plus 2 over x squared all over x times 7 plus 1 over x, right? Now, can you take the x squared out of the radical? And what does it become? It becomes x. Now what can you do? What happens to the x's? They cancel, right? 2 over x squared, 1 over x. Yeah. Try the next one on your own. Okay, so let's look at this one. This one, where do you think you would start? Yeah, let's take out an x to the 6th. When I take an x to the 6th, when I put it outside of the radical, what does it become? So we got a 2x cubed root of the x squared will become good plus 1 minus that 3x cubed. Because I took an x to the 6th out. So I took an x to the 6th out of these two. When I take an x to the 6th out of x to the 6th, I get 1. When I take an x to the 6th out of x squared, I'm left with x to the negative 4th. And this is the x to the 6th, because I got to take the square root of it. Now, I'm going to do a second factoring and take out, x cubed. I'm left with 2 roots of 1 over x to the 4th plus 1 minus 3. So that goes to 0. Square root of 1 is 1 times 2 is minus 3 is negative 1, right? So I get negative some large number cubed. What? Negative infinity. What about this graph? Negative 3 sine of x goes to negative infinity. What's the biggest value? 3? Smallest value? Negative 3? Graph goes like that, right? Does it ever zero in on just one value? No. Okay? Cosine of 5x. What's the biggest value? 1, smallest value. Yeah, the 5 actually shrinks the graph horizontally, right? So, maybe just has like a lot more, ups and downs. So, does not exist. But this one, I got no idea what it looks like. But I could factor out an x, couldn't I? And maybe if we factor out an x, maybe that will tell me something that I want to know. And it does. Because I know that sine stays between what two values? Negative 1 and 1. So would you agree that at best, this would be 3 plus 1, right? Or 4 times a very large number. Or at worst, it would be 3 minus 1, which is 2 times a very large number. Either way, these both go towards infinity. We did work it out. So, our last two examples, okay? You don't, so you can write them down somewhere, wherever you want, okay? Maybe. If you go to your second to the last page, oh, by the way, your very last page, I have this various calculus note sheet for you. So that's for you guys. That's an extra one. I took yours one time. Ooh, should blame me. Why were you doing your homework the night before the test? Whoa! Okay. It says find horizontal asymptotes for the following. Do you guys remember when we would graph something like this, say 1 over x minus 1, and we would put a vertical asymptote here, we draw the graph like so? Well, here's what's really cool. Look at it, okay? What would be the limit of this as x went to infinity? 0, right? Well, look at the horizontal asymptote. What is it? 0. Horizontal asymptotes end up being the limit as x goes to infinity. So it says, find the horizontal asymptotes. Well, we're just going to let the limit go to infinity. Look at it. What's the limit going to be? Can you see? Negative 1/3. The degree is the same in the numerator as is the denominator, right? So you're just taking the negative x over the 3x, you get negative 1/3. If you can't see that, go ahead and work it all out, but get negative 1/3. Now, it's very important that we consider both the limit as x goes to positive infinity and the limit as x goes towards negative infinity. Although I'm a good mathematician, I am not perfect and I make mistakes. I answered a question on an AP exam one time, and I swore I was right. I was about 99% confident, and I got the wrong answer. It was because I didn't consider both sides of it, okay? And I will not make that mistake again. So here's your chance to look at it. Kind of complicated, but we'll be all right. If I go towards positive infinity, okay, am I going to get a positive or negative result up top? Negative. And if I put a positive infinity in the bottom, I will get a positive. So I end up with a negative result, right? So I do get, so you get a negative over a positive is a, so we do get negative 1/3, okay? So y equals negative 1/3 is a horizontal asymptote. Now let's look at the other way. Let's look at the limit as x goes to negative infinity. If you put a very large negative number in the numerator, you get a positive. If you put a very large negative number in the denominator, you get a negative. So that ends up being a negative. So it also is negative 1/3. So my horizontal asymptote is negative 1/3. This is slightly different. Let's try to find the limit here. Limit as x goes to infinity. What do I take out of the top? And I get an x out front, root of 2 plus 1 over x squared. What do you take out of the bottom? And you get 3 minus 5 over x. Okay. Those cancel. These go to 0. What's the limit? Go to 2 over 3. Well, let's consider as we plug in a large positive number. If you plug in a large positive number to the numerator, what are you going to get? Positive or negative? Positive. How about the denominator? Positive. Positive divided by positive is a, so we get the root of 2 over 3. Let's try plugging in a negative. Take a negative and square it, multiply by 2, add 1, take square root, positive or negative? Positive. The bottom, negative. So that will give us a, to get a negative root of 2 over 3. Turns out that when we mess around with that squared, when we take the square root, one side ends up becoming positive, the other side ends up becoming negative. And we really didn't know that unless we checked. So as you can guess, on the AP exam, I answered the top question. But it should have been both of them, and I got it wrong. And I didn't realize, I was like, shoot, I should have checked both sides to see exactly what happens. Question. No, it's not. It's from your book, but it's similar to one that you will see later on when we do some AP review. So these are your two asymptotes. And what's cool is that when you graph that function, you're going to see two different asymptotes for it. So, all right. Again, I rewrote your assignment from last year. I took problems off. It is on a worksheet, front and back.